commands, file system structure. You want to talk to testers in development or software engineering practices. Something about separation of interfaces from implementation. Man, I'm just going through a set of big topics, each of which would be candidates for inclusion in an exam. Interested in discussing aspects of testing or debugging. Who has a question I can bring to the floor? Silence. Okay. I can. I promised you time till 6:30 here. So another thing I could be to go look at some lectures here. So have let's go. So assertions, exceptions, errors. People comfortable with that? When do I use an assertion? So that's a key use, but it's specialized case of a more general principle. And what is that principle? We use assertions to check the logic or assumptions. So the habit to get into with assertions is every time you think, oh, this must be the case because X, because part of the contract function, because there's no way someone, we could get this sort of number out of a number less than 0 out of that thing we just called, out of square root or something like that. If you have some thought like that, oh, this must be the case, or this has to be there, we can count on this, just reflexively write down an assertion. It serves several purposes. One of them is it operationally checks that. If something goes wacko with your code, none of it's impossible. Secondly, it documents. Right? It documents it to someone reading your code in a way that's often crisper, clearer than a comment. So assertions are good for checking. They're sanity checks. That the things you assumed when writing this code are in fact the case. And if they're not the case for some reason, it helps you give some sense that, oh, this code is going to be rewritten. After all, if I write an assertion, they may be really counting on it. Okay, so assertions used for that. How about exceptions?
Are exceptional cases.
Okay, exceptional cases that yes, exactly. They can happen. We're not saying that they should be impossible. They can't possibly occur. They can happen, but they're exceptional. They're unusual. They're fairly rare. And why is it important that they be rare? That they be sort of uncommon? It has import because they've overdone. They're expensive. They require storing away information about layers of context so you can bomb out of there up to the appropriate exception handler. You can unwind the stack. Roll back the stack. In a language like C and C++, that is particular gravity to it. Why? Well, C, the form of exceptions is primal and crude. But in C++, they're more full body, but it still has extra gravity, extra worries associated with it. And what, ladies and gentlemen, are the character of those worries? Memory leaks. You can be rolling back the stack. Foo, ladies and gentlemen, called bar, and bar in turn called Baz. And Baz was called Zap, right? So here we had foo. I'm going to draw it down as Unixes want. Bar, Baz, And it, moreover, has to bomb out of here prematurely, which may mean that certain pointers that were allocated here aren't going to be cleaned up down here. Certain pointers that are allocated here aren't going to be cleaned up down here after this call finishes. Certain pointers allocated here aren't going to be cleaned up. And so all these pointers go we don't have a pointer to this place in memory anymore. We allocated it, but we've forgotten where it is. It's like those old stories of people burying a chest of gold and forgetting where it is. The family doesn't know where it is. Okay, it lies buried, but no one knows where it is, and the family has lost its fortune. So similarly here, when you're rolling back the stack, you may lose the ability to find out where the memory is you allocated, and it remains forever isolated, unable to be free, captive to the confines of the heap, and you lose access to that area of the heap. It's blocked by something which can't be freed up because you don't have a pointer to say, hey, free this. So this rolling back the stack is expensive, and it can cause a leak of memory in C and C++. It's even worse in C. Okay, so assertions or exceptions are extremely powerful. In languages like Java, they're much more safe. Why is that? Because you have garbage collection, and it actually will go free up for you the appropriate memory. It knows if nothing points to this place anymore, it'll clean it up. It'll clean it up for you, and that has considerable advantages in the sense you don't have to worry about your heap disappearing. Okay, so exceptions are expensive. How about return codes? What are some of the trade-offs with those? Exactly. Good. And what are the dangers associated with them? Open to interpretation, you may not handle all cases of them. In Java, for example, you're forced to handle certain types of errors, certain types of exceptions. You either have to say, I might throw this exception, or you have to handle it. If something you're calling, if foo calls bar, and bar throws the exception, either foo's got to handle that exception, or it's got to throw it itself for these so-called types of exceptions. And return codes have nothing that forces you to check them. They might be interpreted inconsistently. A 1 might be interpreted as success in one case by one person and 0 as failure, but by another person they have to reverse interpretation. So these things are dangerous. It's best using nums as return codes, but even so, there's nothing forcing you to handle all cases.
Are there also cases where there's not, like, if the function's returning a float?
Yeah.
And it could be any real number. There's not really one you can pick as a return.
Yeah, although it turns out that if you look at the IEEE specification for floating point numbers, there are certain numbers that some languages will expose, like not a number, NaN, which signals something that's kind of an illegitimate number. So you can sometimes pick those out, but you're absolutely right. It gets really awkward. Like take a assigned int. Maybe you return minimum possible int. So it's like 800000000 hex or something like that. It's sort of the minimum number, but you might not know that that's anything weird. Like you get it back and you do something normal with it without realizing it's an illegal number. So there's nothing that enforces that. Okay, so that's good. Let's talk about. So, do people have questions? If my comments there stirred up questions. Nothing. Oh, this was something I didn't really talk much about. So side effects in functions. You may recall this. I gave this from in the midst of my sickness. I remember putting a cough and a sore throat and putting together this lecture. And I delivered it So here the idea is, ladies and gentlemen, instead of having a long bunch of code together, where we have to visually say, oh, this guy is the same as that guy, and this guy depends on this thing, and so on. The idea is to parse it up into calls, a small bit of code that calls off to functions, where what that function depends on, particular things it needs, is made manifest, it's made clear, it's made visible by the parameters it takes. You can see the code, for example, array total, it's taken out of the code here, up at the top here, and it's put into a function. We can see from its name, array total, what it does, basically. And it's only if we want to see its code that we have to go and look at it. We can change the algorithm later if we want to. In this case, it's a particularly straightforward one, but sometimes we change it from a linear search to a binary search or something like that. And we can do that without changing the code that depends on it, that uses it. We can give it a nice name, which again is clear, and it's very obvious what it depends on. So I had exhorted you as part of this lecture, exhorted you in absentia to put together small functions rather than putting together large sets of code. And ladies and gentlemen, it is my great regret that from this very room, nay, from this very podium from which I speak to you now, that I have seen before me from students more mature in age, but not in coding style than yourselves. I've seen the most horrendous of code, page after page of PHP code, for example, stretching before me like an abomination, with the most heinous of coding practices, repeated code, repeated line after line after line, in the most most sort of hideous of fashions, and you know, having no structure to it, no comments and no indication as to what it's attempting to do, and no sense of where the dependencies are, what's depending on what, and literally page after page of this stuff. The students in this room took great mirth at my discomfort, at my apparent displeasure with this code. And fortunately, I have you and your youths at an earlier part of your career. And I hope when you come in my later classes, perhaps this very classroom, and you bring me my code, I will see something closer to this than I will something like that. This is just a small glimpse of what lies before you, though, when you engage in coding that's that doesn't adhere to these practices. I could only fit so much in these slides. In truth, what this sometimes goes on for page after page, and you are left trying to make out what's going on by piecing through the code, manually tracing visually what depends on what, etc. It's quite painful. Here I actually made use of decent names. In general, that's not the case. People make use of A, B, C, X, Y in the most desperate sort of way. But let me ask you this. Since you've seen further things in the course now, this sort of code, where we call off to functions like this, functions with clear dependencies, with good names, etc., they actually help at several different levels with other processes too. Could you mention to me, ladies and gentlemen, two other processes that we've talked about since your eyes first beheld this code, or at least I hope they did? Two other processes associated with building software, which would benefit from code where you have clear functions carved off, and not where all of it is mixed together in one big hairball. Okay, so you could have a make file for different pieces of this code, for example. I could imagine that. Good, yes, that's right. So instead of just repeating the .o files again and again, grouping them in one place, so abstraction helps there as well. Yeah. Good, good. So if you have failure, you could figure out sort of where, from which function it occurred in a sequence more quickly. Yeah.
Would it be easier to find where differences were made in SVM and get reports?
That's right. So instead of occurring at 5 different places in this line here, all the changes may have occurred in the array total function, because it's now called 5 different times instead of being repeated in line. And believe me, if you don't believe that happens, you got a thing coming. Just please don't put it in front of me. So that does happen, and that would allow you to more crisply see where those changes logically have occurred. It's occurred logically with respect to how array totals are done, but previously it might have been splayed out in a bunch of code. Okay, so what other things? Tests. Big time tests. Testing a thing that's line after line of code. That was one of the things that was most disconcerting about this code I was looking at, because they were saying they were having terrible times getting their site running. They couldn't test it effectively. They didn't know how to test it. Well, if you have 200 lines of PHP code straight, and you're trying to test different subcomponents of it, how are you going to do that? You can't really. It's like, oh, I lack an analogy. Words fail me, ladies and gentlemen. But you know, it's hard to test something that's in the middle of a bunch of other code. You got to somehow get tests that wind their way in there to hit just that code. It's much harder. If you have a function, you can write tests for that function that are specially aimed at that function. And then, of course, the function can be called from this code. There's no problem with that. But by carving it out, you can deal with it as a unit, and therefore test it, ladies and gentlemen, as a unit, instead of just testing the whole system at once in all its hairy hideousness. Yes?
I was going to expand on SVM if you're working with other people.
Yeah.
And have more like distinct specified contracts that people know more or less exactly what function.
That's right. So if people, you could basically have different people work on different functions here at the same time, right? And each is responsible. And as you've seen from Subversion in Lab 11, if one person checked in a function and modified array total, another person checked in a function and modified this code, and another, checked in the same file but modified a different function of the code, they can be checked in at the same time without a conflict. It's only if they're working on the same code that there's a problem. And ladies and gentlemen, if it's all tied together here, you're more likely to have conflicts on this code rather than conflicts by working on separate functions. Okay? So you might modify a variable name here, and it leads to changes all throughout this code, for example. So yeah.
That brings up a question for me.
Yeah.
Like, what's the correct syntax that SVM is back?
Yeah. It's basically recognizing the changes occur in different lines. And so they didn't touch different lines. They touch different. It's not very intelligent in the sense that, suppose Harry checked in code which had well, Sally checked it in first. So suppose Sally checked in code which had, square root with one thing in it, and then Harry checked in code later. So maybe this is in foo, the foo function, right? And then later Harry is editing the square root function, and he inserts, 2 arguments for this or something, and she's checked hers in like this. He checks in his code with this. Maybe this is new code that she inserted. It's not going to recognize that semantically there's a conflict here, like that this should be updated. Subversion's not smart enough. It'll say, oh, she made her changes to those lines, Harry made his changes to these other lines, or hunky-dory, and check it out, okay? So good question. I would also note, ladies and gentlemen, after your experience with GDB, testing or debugging this code is a lot easier than debugging this one, because you can just skip through each successive function call. There's that difference in GDB between going through executing line by line in the current function versus, well, let's put it this way. You can either step into a function call or step over a function call. You can have the function call occur at once, or you can actually go into it and step into it. You have that choice. Here, you're talking about line by line by line by line. What things do I expect you to know on, so this code is just, it's much easier to do, much easier to do. So, what things do I expect you to know on GDB? Riddle me this. I do expect you to know something about backtrace. How backtrace works. How you can select frames associated with backtrace. Select frame. So these are stack frames like these up here on the board. Foo, bar, bat, zap. I expect you to know something about how you can run a program, taking arguments for arguments for it. So you could specify, for example, run, type in from a file, or run and give it a command line argument from within GDB.
If there's a whole stack like this here in GDB,
Yeah.
and say your current focus is that, because
Yeah.
right at the bottom, and
Right.
you jump up to bar,
Yeah.
does that actually remove zap and bars, or are you just changing both?
So
If you go
no,
up,
no, it does not remove it. So if you say select frame bar,
Yeah.
you know, the select frame for the bar frame, it does not in any way roll back the stack.
Right.
So it's still all there in front of you, but you've just changed your point of reference. You've changed the frame to which your variable names will refer. So where this really becomes relevant is, of course, you want to be able to say print A, and maybe A is a variable in bar, right? Maybe there's another A in zap, and you want it to be clear you're referring to this A, so you select that frame, or you select this frame for this, but it doesn't change the stack at all.
right, yeah.
Okay. So good comment. So I do expect you to know that you can step into a function, or you can step over a function. Sorry? I'm trying to remember here. I think one is N for next, and I think another is S for step. But I'd have to double check that. My recollection of that. Okay. There's also C for continue. Continue on. Or you could type continue. These are short names for names. There's P for print, right? To print out the value of some expression. And so you can print, for example, that, but it's an arbitrary expression. And something to quit out of it. What else do I expect for you as a key command? Breakpoints. Understand the notion of a breakpoint, and knowing that breakpoints can be conditional. You could say breakpoint under these certain conditions of BP, and you can have a watch point. The notion of a watch point is like breakpoint. It basically says, hey, break the execution or stop the execution of the program when a certain condition occurs. But the condition is different. With a breakpoint, it's you have reached a certain place. Watch point, it's what? Yeah, and particularly it's when a certain variable, for example, has been modified, or a certain element of an array has been changed. The thing pointed to by a pointer has been modified, or some expression has changed. So a watch point versus a break point. Let's see. Any other big things? Well, obviously, if you should know that GDB can wake you up if there's been an obvious error. So if there's been something like a null memory, so null pointer use, or if there's been a bus error, if there's been a segmentation fault, it may wake you up. You know, you are currently in zap, and that's when the null memory access occurs, or another thing you should know also is that variables can be changed in GDB. So if I'm looking at the value of A, maybe A right now is 3 or something like that, I can change it so that A is 4 and actually continue execution. That's the kind of, what's that?
Awesome.
Well, the reason you might want to do that is if you think you found the source of the error and you want to test if you fixed it, would it be fixed if you tried this? If it was off by 1, you want to see, hey, if I fixed it this way, would it work? You could do that kind of in situ, in place. So you should know that you, in fact, can do that. So those are some of the main comments on GDB. And of course, I do expect you to know that for GDB to work, you need to compile a program to store symbols up. That's what the line of G option needs to be compiled with the line of G. What does that do? It stores up a bunch of symbols, so it knows what A is, the names, the nice English names of variables, and it knows what the names of the functions are, and what particular line of machine language code lines up with what line in a given .c file, .cc file, etc. So it knows kind of where things come from in the .c or .cc files or .h files. So it sort of wraps up all that information in your .o file so that when you go to debug it, and in the executable, so when you go to debug it, it knows what comes from it. Okay. I think time is running on. I'm going to be holding another review session for the final exam. Are there any final questions? We do. Tomorrow's the last day of class. I will, however, be holding office hours.
Just to be sure with GDB, if in that instance A is a pointer, if you were to just do print A, it would print on the address.
Correct. It'll print actually by default in hex. So OX 7F, BA, CH, or something like that. Right. I will. Good question. I will test the material before the midterm, roughly probably half as much as the material before after the midterm. So sorry. Roughly speaking, yeah, something like that. The reason being, some people had a rough time with the midterm, and I don't want to just not let them demonstrate better mastery of that. But at the same time, if I've already tested people quite a bit with respect to that, given the limited space available, I really want to use it for the rest of the material. I will have some from before the midterm. After all, this is a 3-hour final, not a 1.5 hour final. That is something that is being debated right now. Let's put it this way. I'm torn greatly by this. Making it multiple choice means that the marking effort is markedly reduced. And what that means in practice is that probably I don't spend my Christmas marking exams, because commonly exams I mark, it takes an hour per exam or something like that, and I have marked every single one of the exams for that help. So that's a lot of time. You can imagine that. There goes my holidays, right? At the same time, stuff that's hard to test. So I'm thinking about it a lot. I haven't come up with it. I know. Yes, I'm thinking about it. I think about chimeras or griffins. The face of beauty that launched 1,000 ships in the body of the beast. Yes.
If we were using some of our mark factor stuff, like I would think we got mark factor some of the ones.
Okay. This is was assured that assignment 1 was handed back. Is anyone else in that position? I believe I am. Okay, so I don't know what's going on. What I do know is that 2 out of the 3 TAs told me that was done a long time ago, and one of the markers said he was behind in it and that he would be submitting it shortly after I talked to him about it. I had the impression 4 weeks before that it was basically done. So this is a great concern for me. So I appreciate you letting me know. I thought it was
Yeah, that's good. Yeah. I also feel like I don't know how you guys divide the work among the TAs, but I feel like once we're done marking all the labs, the assignments come back.
I think that's exactly right. That's exactly right. Because you've been getting the lab marks.
Oh yeah, labs are very I got to 8 for labs.
Yeah, I've got 9.
Okay. No, but that's a bit reassuring. One of the markers, the marker at issue, I mean, he's got a lot of classes.
It's just like his assignments are like what 25%.
Yeah.
Like to know that for
Yeah.
final. But I mean, there's certainly adequate time. There's still like 15 days.
Like 1.5
Yes, yes. You're absolutely right. I appreciate you letting me know that this is still an issue. I did think that it was resolved. I'm meeting with the markers on Wednesday, so I'll be taking this up with them as a top priority. In fact, tonight I'm sending out, like, up to this particular one.